Our story begins with an inquisitive young boy, Kid Kevin, who shouldn't be in the lab without supervision. But that's another story.
Don't eat that! It's diazepam!
What the fudge is diazepam?
Did someone say diazepam? Diazepam, also known by its brand name Valium, is part of the benzodiazepine family, typically known for producing its calming effects.
That's cool. When was it invented?
That's a good question, Kevin. Diazepam was the second benzodiazepine invented after Librium. It was developed in 1963 and was 2.5 times more potent than its predecessor, making it the top-selling pharmaceutical in the US from 1969 to 1982. Its success helped Leo Sternbach, its inventor, and Hoffmann-La Roche Pharmaceuticals become a pharmaceutical giant.
Okay, but how do you make it?
Let me show you, Kevin. As you can see here from steps 1 through 6, this is Leo Sternbach pathway. However, it is too long and also cost ineffective. Therefore, today, the more common pathway is what you see here from steps 1 through 3, shown in green. This is faster and is easier to make. Now, let me show you how this is being made. Our starting material is 2-amino-5-chlorobenzathine. It reacts with ethyl glycinate. The amine group reacts with this ester group here. As a result, ethoxide leaves, and our amine group here kicks out oxygen and forms a 7-membered ring as we see further below. Then, a negatively charged oxygen reacts with the amine group here and forms water that leaves. This gives us our benzodiazepine core. What remains now is to react it with dimethylsulfonate to methylate it and give us our diazepam.
Well, what is it used for?
Well, that's a good question, kid. Medically, diazepam is a Schedule IV drug that is used to treat anxiety, insomnia, panic attacks, seizure, along with some pain management cases. Recreationally, it is a drug of potential abuse. It gives euphoric sensations, as well as enhances the effect of alcohol. A relatively recent case where diazepam was a main component was the recent death of Michael Jackson.
Man, I love Michael. What does it do in the body to cause all these effects?
That's a good question, Kev. For example, everyday people get stressed out like this college student cramming for an OChem exam.
What the hell is mustard gas?
But let's go to a microscopic level and demonstrate how it works. So let's pretend this tennis ball is a molecule of diazepam, Kevin, and near the GABA receptor, which acts as a chloride ion channel in the body. When diazepam binds like this, it causes a conformational change. This change causes an influx of chloride ions into the cell that causes it to hyperpolarize. This ultimately leads to its calming effects. Now going back to a macroscopic level, look what happens after this college student takes diazepam. He's still gonna fail, but doesn't he look so calm and relaxed?
Dang, he does look relaxed. Oh wow, so I think I understand it. So GABA A is like a stoplight that's always on red, but when diazepam binds to it, it turns green and lets all the chloride ions in and hyperpolarizes the cell and ultimately leads to all the calming effects, right? Where'd they go? I want to be like Michael though.